Hello, and welcome back to my YouTube channel. My name is Professor Gavala, and today I will be talking to you about the CMOS Full Adder. And in order for you to understand everything in this video, you must check out the inverter, the CMOS inverter video that I posted earlier, and the NAND and NOR gates, which are clearly explained in my previous videos. So in order to start, we need to first consider the type of inputs and outputs that a full adder has. So for the inputs, we can consider a C-in, which is basically the carry in from a previous circuit, the first input and the second input, and these can have different combinations. Where we can have 0, 0, 0, 0, 0, 1. Let me try and get that in there. Yep. 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1, 1, 1. And my outputs that I can have are that same a C out or a carry out and a sum, which is the adder portion. We'll start with the sum and go to the left. So for the first part, we get a 0 as our sum, and the carry is 0. For the second part, we get a 1. For the third, and 0 is our C out. For the third part, again, we get a 1. 0 is our C out. For the fourth part, we get a 2. So this is 0, 1. And for the fifth part, we get a sum of 1, and the carry out is 0. For this, we get a 2 again, so this is 0 and this is 1. And here we get 2 again, which is 1, 0, and this here is 3, which is 1 and 1. The way you can look at this is this placeholder is 2 to the 0, and this placeholder is 2 to the 1. Where, again, if I had a decimal value portion, I would get 0, because 0 plus 0 plus 0 is just 0. 0 plus 0 plus 1 is 1. 0 plus 1 plus 0 is 1. 0 plus 1 plus 1 is 2. And essentially, this, in order to get 2 in binary, we would have to go to this placeholder. So that's why this carry out is 1, and this is 0. 1 plus 0 plus 0 is 1. 1 plus 0 plus 1 is 2. Again, that's why we have this 1 here. And 1 plus 1 plus 0 is 2. And lastly, 1 plus 1 plus 1 is 3. So we get, this is essentially, this is 2 to the 1 plus 2 to the 0, which is 3. So I hope that makes sense of how we obtain this truth table. And now we want to consider the gates of this full adder, which I will go to this next page here. And we want to consider the sum S. We want to consider values for the sum S. And in order to do that, we consider when is S equal to 1, right? And we add those up together. So it would be here, 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 and the last one. And if A, B, or C in are 0, we say they are a complement. So for example, I would get, for this first part, I would get C in not A not B plus Cn not A B naught plus Cn A naught B naught plus Cn A B. I hope this makes sense. This will equal to, I can pull out a Cn naught. I'm left with A naught B plus A B naught plus Cn A naught B naught plus AB. This is equals to Cn naught A XOR, which is a plus with a circle through it, B plus Cn X NOR, which is an A and it's a dot with a circle over it with a B. And just as a side note, to understand the XOR gate, which was talked about in the previous video, again, please make sure to check that out. The gate symbol looks like this. Oops. Where this is A plus with a circle, X NOR B. Inputs are A and B. And what it looks like is we take a B, we invert it, so this is a NOT gate. We invert it with A, and then we AND it. So this is A, B, NOT. And we do the opposite to another NAND gate here. So we NOT A, and we AND both of them, so A NOT B. And then we pass this through an OR gate. Which is A, B, NOT plus A, NOT B. And this, so if I were to put so these two are equivalent. Now, if I were to put a red box around this, and send this to an inverter, this is a NOT, what I would obtain is a X NOR gate. So an XOR gate, X NOR gate, so X NOR gate is basically an XOR gate that is inverted. And the symbol looks like this. A, B, and this is X NOR B, or another way to write this is A XOR and then inverted or knotted. So I hope this makes sense in terms of what an XOR is and an XNOR. And what we can do is we can transform our sum to be Cn A plus B XOR B plus Cn A XOR B not, and S is equals to Cn XOR A XOR B, which is equals to Cn XOR A XOR B. So that's the sum of a full adder circuit, and the carry C is equals to A B C N not plus A B C N A not B C N plus A B not C N plus A B C N. And the way where I get this from is going to our C out. Here is one of my summations. Here is one of my summations. Here as well. And last but not least, this last one. So these four make up, these four make up C out, which is what this is how we got these values. And we could simplify now and say C in A naught B plus A B naught plus AB C in naught plus C in. C in naught plus C in is equals to 1, right? Because x not x, if I do 0, 1, 1, 0, this would always be 1 and 1. It's x plus x naught. So we can simplify this now to say A x nor B. All right, this is AX nor B. Cn plus AB is my carry out. So for a full adder, the full circuit will look something like this. So if we have Cn, we're going to pass this through an X NOR. Just bear with me. So we have this kind of going backwards. So let me do A, B. This goes here. This goes here, here. This is XORed. Comes in. This goes through an AND gate. This goes through an AND gate. This goes through an OR gate. And this is the carry. And this is the sum. So to break this down, if we start with the carry, we notice that A XOR B is right here. A XOR B. We AND it with a Cn. So this is A XOR B and Cn. And then lastly, we OR it with an A and B. So here's A and B. And this is essentially equals to A XOR B Cn plus AB. And for the sum, it's A XOR B, so right here. And we XOR that, A XOR B XOR Cn is equals to the sum. And we see that right here. Cn XOR A XOR B. So now, when you want to draw a full adder on your schematic or symbol, you would just say it's a 3-input device, C in or clock in, A, B, and C out or a C carry, and then the sum. And we put a full adder in the middle. So I hope this makes sense. Again, the fundamentals need to be understood in terms of the inverter, and then creating an AND and OR gate from the inverter, and then we can easily create more complex devices such as the full adder. In the next video, I will be talking more about configurations and devices like the full adder. So please like, subscribe, and share my videos. Thank you.